Okay. Can we move on to routing? Now you guys all have the code? Perfect. All right. So it's very unlikely that any non-trivial app doesn't have multiple pages. A good example of this is login pages are very different from a dashboard page. Settings pages are very different from a home page. A buy page is very different from a input your credit card page. You could have everything inside of one page and do ng show and ng hides and all that fun stuff, but that's really complex and it's not intuitive. So Angular provides a way to do routing. Since you guys are doing Angular 1.2, what I'm about to say doesn't matter, but I'll say it anyway. Starting in Angular 1.1, Angular used to have routing embedded inside of it. It is now becoming more and more modular, so they're starting to rip pieces out of the Angular core and add them as other modules. So if you are using ng-route, you have to have another file. The other file in ng-route is, you can grab that from angularjs.org. You click on here, click on the big download button, and click on browse additional modules. You'll see there's a bunch of other little modules. You can grab ng-route from right here. Okay. So in order to actually use it, you obviously have to load it on the page. The other thing is that the ng-route needs to be defined as a module, jet lag. You'll have to define that as a module level dependency inside of your application. Remember those brackets when we created our module? This is where module level dependencies go. So we have to put the ng-route inside of there, just like that. Then we need to define inside of our view, inside of our page, where this route will go. We need to place it on the page, for instance. So pages, modern web applications, you generally don't want to switch the entire page. You generally just want to switch components of that page. For instance, the Facebook settings page looks very much, the header and the footer of the Facebook settings page is the exact same as the header for the, is it called a dashboard page in Facebook? I don't even know. Your home route, timeline route. You guys get what I'm saying. The header and the footer stay the exact same while the inner part switches. In Angular, we call these layouts. So we have to lay out where our view will go. So for instance, if we were using ng-route, which we're not going to be using here, but if we were using ng-route, you could place like the ng view inside of here. So you keep the header and the footer the exact same regardless of the page, and you just switch out that component where you want the layout to change. I'm gesticulating a lot right now. Okay. So the way that works is ng-route will switch the child element. It will switch the components. It will switch all the child elements out and put in the child elements in for the new route. So if you're going to have a settings page, that div, this div here with ng-view will stay put, but all the child components of it will change depending on the view that you're on. And then inside ng-route, I'm only keeping this in here because you could use ng-route. We're going to talk about UI router because it's slightly more complex. It adds additional features, but I'm leaving this in here because if you are using ng-route, that's cool too. ng-route is just a little bit simpler. We would define these routes on top of a route provider just like that. And then this is the same as UI router. When you want to define a route, you use the when method, and the when method takes two arguments. The first one is the route that you want to match it against. In this case, there's only one route. It's called the home route. And then the second one is a route descriptor object. And then you have this otherwise method, and that's if no route matches, and it will pass back to this otherwise method. Hooray. Okay, now stuff that's relevant to us today. We're going to be using the UI router. The UI router, unlike the ng route, is a state-based router. ng-route is a URL-based router. The reason why we're going to be talking about UI router is because it's a lot. It gives us a lot of more advanced features than ng-route. ng-route is very simple. It allows us to switch out a page for another page. UI router allows us to have multiple pages that we can switch out on the page. So for instance, if we have two views, we can switch out those views independently of each other using states. We can also inherit from other states, which is pretty awesome. Cool. Similarly to the ng router, UI router is another module. This is a community module. In order to use this community module, we have to include this on the page. So let's go to our code real quick, to our index.html, and to our index.html and reference this route, just like that. Oh, no, I lied. Just like that. It needs to match the name of angular-ui-router.min.js. Or if you don't have the minified version, then without the min. All we did was, yawn. Sorry. All we did was we changed this guy out. Okay, moving on. The second thing that we'll need to do is we'll need to, what's your name? What is your name, guy with a list on his computer? What's your name? CJ. CJ? We had to do another thing with the UI router, or the ng router, to make it work. What do we have to do with the, we have to do the exact same thing with the UI router. Do you remember what that was? We have to add it as a modular level dependency. Right. So if we go back in here, in order to actually use the UI router, we have to set this as a module level dependency in the brackets. So now we have a single dependency before our module can load. Sweet. Any confusion about that? Huzzah. Okay, so similar to the ng route, or ng router, we have to lay out our page. We have to tell our UI router where we want the views to sit. If we only have a single view, then we would use just UI view. Instead of ng view, we'll use UI view. Okay, so let's go take care of that now. So we're going to take all this hard work that we had. Actually, no, I lied. We will do this in two views. If we want to create a second view, or I'm sorry, let's say, so we have our app right here. Refresh our page. We make a call. There are two views, two potential views inside of this. We have our nearby businesses, which is one view, and then we also have our if weather loads. If weather loads, that's another potential view. So we'll create two different views for this, and we'll create two different named views for this. Right, so the first thing that we're going to do to create two different named views is we're going to rip out everything inside of this row. Oh no, all our hard work, it's gone. Let's create another file, and we'll call this file the weather.html. Save it and pop in what we just deleted from there, inside of there. It's okay, you can do this right now.
What do you get the UI route?
It should be on that USB stick that we passed around. Okay, so we literally just ripped everything out of that row and put it into a new index.html or a weather.html. That's all we did. We're going to do the exact same thing with the weather, with our weather. I'm sorry, our Yelp nearby.html. We'll just paste everything inside of there. Okay. Does everyone's index.html look barren? Mine totally does.
Does it make sense to separate the search bar button from the weather?
You know what? I was too vigorous. You're right. My bad. It does not. So if we're doing that, shame on me. That's what I meant to do. Okay, so now it should look like this. So we still have the search bar in there, but we have nothing else inside of here. Okay, so in order to create our named views, what we'll do is we'll create a new div, and inside this div we're going to use the UI view directive, which is simply a function that runs on an element to augment its functionality. We're going to pass in the name called weather. This view, this weather view here, is a named view that sits inside of the state that we're in. And we'll talk about that in just a second. And then we want also to pass in nearby. Make sense? Great. Okay. So in order to define a state, we're going to have to use the config function. Here's where I get to describe a little bit more of the digest loop. The way that Angular works, from a semi-low level perspective, is Angular itself, the library, when you load the library on the page, when you say script tag lib angular.min.js, what happens is Angular makes a hook into the DOM ready event. So when after the browser has laid everything out, it's done all its parsing, it's laid everything out, and it's put all the CSS and all that fun stuff on the page, and it's ready to go, it fires, because the browser is an event-driven application, it fires the DOM ready event. When this DOM ready event is fired, Angular says, oh cool, now I can go. Angular itself will do its own parsing of the whole DOM. It will look for things called directives. This is called the compile phase. It will look for directives, it will look for the squiggly brackets, it will look for anything that it knows about, and it will compile that. It will compile it into its own little runtime objects. At the compile phase, nothing is running. Angular has not run anything yet. After it's done compiling everything, it will call configure in the module that it's running. It will call the .config method. And then, after that is run, it will call the .run method, and then run will go and do its thing. And then our application, after the run method gets fired, then our application will be up and healthy and ready to go. The config function is specifically designed to allow us to configure the states of our application. Yes, that's probably enough. I don't need to go any deeper than that. If you want to know more, I know a book that can help, or you can just ask me after the class. Either way. So in order to configure the UI router, we're going to call the config function on this thing called the $state provider. And then we're going to attach methods. We're going to attach states on top of the state provider. So we'll call the config function, and then we'll inject the state provider. I don't know why I almost said projector. We'll inject the state provider into this config function, just like that. What? Huzzah. Okay. Okay, so remember before how I said that views themselves, nope, I'm not going to do that. That's okay. That's a little more than we can do right now. All right, so in our state provider, what we want to do is we want to define a couple states. Actually, in this case, we're only going to define a single state. And that single state is going to be the root state. The way that we define a state is by, it's very similar to the way that we define a route. We say .state on the state provider, and then we give the state a name. In this case, we will call this name the root state. And then the state itself takes a state description object. And this state description object allows us to assign different variables for that specific state. So for instance, if we want this, I'm just going to give you a for instance, and then we'll go into actually writing our code. If we want our state to be populated when we have a different route, we can use the URL. And so if the page loads up at the / URL with nothing past it, it will load up in this state. We can also have it, let's say that we just actually want it in root like this, or admin. We can do that exact same thing. So this state, after Angular's has booted our application and we're at the /admin page, then this state will load up as opposed to another state. In this case, since we're just creating a root URL, we'll just have it be a /. We can also define the controller that we want inside of our roots. So in this case, we could have a home controller, for instance. My bad. We can also define a template specifically that we want. Hello, welcome home. Just like that. And we can define also multiple views. I also just realized we won't be able to get to testing if we do multiple views like this, so guys, don't hate me. I'm totally just going to do this. Okay, so what this says, I am totally taking this out and going back in my Word to do multiple views, but that's okay. You guys will have access to the slides, and I know a book that can help. So you'll see at the end. You'll see at the end. So instead of doing multiple views like that, I'm going to do home.html. Paste that guy in here. Paste the nearby in there. And then paste the weather. Okay. So what this is doing is this is creating an anonymous view. It's an unnamed view. It just makes it a little bit easier for when we're building our state. If we have time at the end, I'll show you how to do multiple views, but there's great documentation on the UI router page. So if we don't get to it, that has fantastic documentation. And I also know a book and a website that can help. Okay. Right. Okay, sorry for the tease. So we're only going to create one route. What this will do is this will allow us to switch out whatever is inside of that page, inside of that route with whatever is in our template. So if we come back here to our app and we load the view, nope. We load the view.
You didn't load the template. Native home.
No, that's okay.
Load the template.
Yeah, it's right here. Oh, wait, I know what's going on. Nope, I lied. That's not what's going on. No, that should still work.
Did you switch it to home.html?
That doesn't matter because I'm actually passing in the template. What am I missing?
Do you need the server from the server?
What?
Do you need the server from
Not yet because we have a template. We will have to do that shortly.
your own match?
What?
Will the URL match though?
It should match it. How embarrassing. Oh, already defined. Oh, that should still work. Root. Maybe not.
The UI router GitHub page, they show loading and all in the head as opposed to at the end of the body.
That doesn't matter, actually. So the reason why you want to do that, why you want to load this to the end of the body is because the browser will, in order, sequentially request these files. So if we want to show, oh, here's one thing. So if we want to show our, well, that's funny. Okay. Well, we will do this real quick. So if we want to show our, where's the otherwise? I totally forgot. I think it's URL location provider. So if we want to, wait, what were we just talking about? I totally forgot.
Scripts in the head versus
Right. So if we want like the page to appear that it's loaded, and let's say you're on a handset and you're driving really fast through Texas and you're going underneath the tunnel, you still want the page to load to make it look like something's actually happening. If you put it at the end of the body, the page will load and it'll look like something's actually happening. Whereas if you put it in the head, then it has to request all those files before it even shows any of the body. So it's good practice to put everything at the end of the body. In fact, I have a really lengthy blog post about how to make a splash screen for this specific purpose. Okay, so I believe this is,
Why did you mention in the home.html URL needs required?
oh yes, I think you are right. Okay, cool. That was embarrassing. It was, okay. You guys still trust me, right? Okay. It's been one of those days. Okay, so notice that what we've done is we've set up a welcome home. We've just hard-coded the template for this page. That's not really that easy to edit, especially if you're writing your HTML. If you're writing all your HTML inside of your JavaScript, then your JavaScript starts looking like Backbone, and that's one of the reasons why you left Backbone in the first place, because it sucks to write your HTML in JavaScript. I know. So what you can do instead is you can pass in a template URL, home.html from my web page, and we'll use that instead. So a problem arises, though, if we're doing this, and that's we get this fantastic little error saying that we can't load from our file / home.html. The reason we can't do this is because it's cores. We talked about this. So in order to actually have this running, this is why we need our server. In order to actually have this running, we have to launch a little server, and we'll use Python to do this. And we'll launch that server at port 8000. The simple HTTP server that I'm running right here simply, let's restart that. All this does is it serves the current directory as at a port. It's really simple. It's really easy. So if we want to load that, we can load that localhost 8000. Oh my goodness. Sorry guys, I just changed my key mapping yesterday for some reason, And now every single time that I do something that I used to do a lot, I switch to the other view. Sorry. Okay, so in order to actually get this to load, and you can see it's loaded right here. In order to actually get this to load, we have to just start up this simple HTTP server. So if you're following along still, I insist actually that you do follow along. So everyone here who has a Mac has Python installed. If you don't have a Mac, I can't help you. Do you want me to do that right now? Would that help? Okay, yeah, I will. Okay, it's updated. Okay, cool, look, our home page worked. So inside of our index.html, to kind of prove that it's working, let's add a your daily app. We'll just add a nice little header. So we refresh the page, you'll see we have your daily app. And any view that we go to will have your daily app inside of there. Oh yeah, I know. Thank you, by the way. Okay, so you might notice something is wrong here. If we type San Francisco, California, and we press enter, nothing happens. The reason why nothing happens is, let's see, sorry, excuse me. Okay, anyway, the reason why it doesn't work is because we don't actually have a controller assigned anymore. So we can get this back to work if we can simply just pass in home controller inside of here, and it cleans everything up. So now we don't have to hard code ng controller with home controller anymore. We can simply use the route to do it for us. So if we come here and refresh the page, we'll see that San Francisco, California automatically populates for us. We press enter, and all is well in the world. The weather does not like me today.
They've just been taking a while to respond.
Yeah, it was, for sure. Cool, and everything still works the way that we expect it to work. Huzzah! The cool thing about this is now we can switch in between different views. If we wanted to add a settings view, so rather than type in your location every single time, you have a settings and you save that setting. We don't have the time to do that, unfortunately, right now. And you save that setting, then you can switch over to that view. For instance, if you're building a Chrome app, for example, you can switch over to that view. You can save that setting, come back, and every single time that you reload the page, you can just have your weather populate and your nearby local businesses. Yeah, I thought I just did. I'll do it again. It should be on there. You should actually home.html is on at the bottom. Okay.
What was the new link that you put it on?
It's the same, should be the same URL. Yeah. Okay, I'm going to take a quick poll. Are we good with routing? Can we move to testing, or do we want to spend more time on routing?
Testing.
Okay. Okay.
One question.
Yes.
Check with heights at the end because I mean, if that is the case, you just switch to testers.
I already did.
No, but this current version.
I just did.
Okay.
Just refresh the bit.ly link.
You just changed it just a second ago.
Yeah, like,
Yeah, there's no config in the app.js.
isn't there? There isn't? Oh, well, that's funny. Okay, you guys are right. I'm totally wrong. I thought I did this. Oh well. Okay, try it again. j.mp/re app.appjs, just like that. Okay, now try it. Should be the same, or it should be updated. Is it updated? Okay, sweet. Let's move to testing, because we are going to write tests now. Okay. If we have time, and I can stay a little bit after. We can look at multiple views if you guys are interested. Excuse me. And abstract states, which are really cool. All right, so testing. So testing is really super good. There's no argument that testing is bad. I don't know any argument, except for maybe it takes some more time to write it. But that's time well invested. So there. Okay. Okay, so the Angular team built a couple tools for testing. They originally built this thing that today is known as Karma. It's a test runner that runs in a browser. We can have it run in a headless browser, or we can have it run in headful browsers. I don't think that's what those are called, but I like the term headful. Karma, little known fact, Karma was originally called Testacular, but changed for obvious reasons. Okay. So unit testing, what we do when we unit test is we test small pieces of code. We test consumable pieces of code, things that we, from our code perspective, want to make sure run. All right. So the way that we can start running tests is we have to download a few modules. The first one is the first two are Karma-Jasmine and Karma-Chrome Launcher, just like that. What?
That's not going to work on Windows.
I don't know how that works on Windows. I'm sorry. Okay.
I think, there's a Angular Mox NPM and Bower module.
There's a Bower module. There's not an NPM module, though. So yeah, that's why we had to do it like that. Okay, so I will put this on that gist, so you can copy and paste this from here. Okay. So one thing that we'll have to do with this installation is we'll have to touch package.json in your local directory or type npm init. That's a crazy name. We'll just call it my app. I forgot to say, type npm init in your local directory to create a package.json. By the way, these commands are on that gist, so you You can copy and paste it from the README on the gist. My current speed is 0. That's really unfortunate. Well, not anymore, but it was 0. You know something's wrong if it's 0. Okay. Do you guys all have those commands? Have you run the commands? If you're on Windows, I'm sorry, I don't know how to do it. Yeah, just type npm init and press enter a whole bunch of times. You don't have to do that. Just take off the -- save dev. Okay. So next what we need to do is we need to init our config, our Karma config. Way that we'll do that is if you successfully installed everything, you should have a node_modules directory in your current directory. Type node modules karma bin karma, just like that. I understand. Is your speed 0?
I'm not even at the pro yet. I think you better just move on.
Yep. I'm just going to demo this. So stick with me. Okay. Okay. So in order to create our Karma configuration file, we'll use the init command in the Karma tool. This will ask us a bunch of questions. I personally like to press enter on all those questions and manually edit the Karma config. So if we come here, the file that it created was called karma.conf. This will be in your current directory, wherever you loaded it. And it will create us a nice base template for our Karma config, so we don't have to type this manually. So in order to actually run the way that Karma testing works is it launches a browser, and it loads everything inside that browser. So in order for us to load our application inside our browser and all of our required files, we need to list those files for the browser to load. That makes sense, right? It does this programmatically. So first thing we have to do is we actually have to load Angular itself. We have to load Angular UI router because we set that as a dependency. Then we have to load Angular mocks. And we have to load our app.js. And finally, we have to load all of our tests. So in this case, our tests are going to be in a directory that we're going to call spec. And all of our unit tests will be underscore with test, just like that. It'll be a file name with underscore test. So let's go create our spec directory now. And we are going to make a home controller test, just like that. So now I have this empty test file. Okay, so now in order to run, oh, it's the internet, otherwise she would be available. Making me want to try it. Siri, are you available? Okay. So in order to...
I have nothing on my calendar, if that's what you're asking.
So cute. All right. So in order to run our unit tests, we're going to use the Karma command called start. And then in order to run the Karma command, in order to run the test, we need to pass in as the second argument the configuration file. So if we press enter there, we'll notice that another browser is loading behind us. Hooray. This is the browser that has all of our tests. Eventually we'll have all of our tests running. You can see that programmatically, if you can see that, I don't know if you can, programmatically it is loading all of those files that we told it to load. Hooray. But we don't have any tests written, so let's do that now. Okay, sweet. So in unit tests, we're testing composable pieces of code. So if we come back here, in this test, we're going to test our home controller. So our home controller has a couple things already associated with it. It has a scope, a weather service, a Yelp service, has 3 methods, one called fetch data, one called get weather data, one called get Yelp data. So if you guys are not familiar with Jasmine syntax, this is all Jasmine syntax. Jasmine.js.com, I think, has all this documentation, or just do a search for Jasmine.js on Google. It's awesome if you've never used Jasmine before. It's a great BDD. It's great for BDD. Okay, so in this test, we're going to be testing the home controller. There's a couple things that we have to do in order for our test to run against our home controller, to actually set up our home controller tests. When you're testing, what we're trying to do is we're trying to set up conditions that we want. We're going to set up conditions that we want to set expectations for our tests. So if under certain conditions our tests work the way that we expect them to work, then they will satisfy our expectations. If our tests fail under conditions that we expect them to work, we know we have a problem. This is the definition of testing, is we're trying to set up the tests such that they match our expectations. So what we're really doing when we're writing tests is we're setting up a bunch of expectations. Make sense? Cool. It's kind of like when you're testing a car and you're taking it around a mountain track, and that mountain track is 8 feet wide, and you're zooming as fast as you possibly can. You're testing but never mind, I was trying. Okay. All right, so in order to test controllers, what we actually want to do is we want to test the scope of that controller. So what we'll do is, I introduced that a little bit early, but that's okay. What we want to do is we're going to set a local scope object inside of our tests, and we're going to set that scope object with a bunch of different fun things. We'll see that in a second. Before we can do that, we actually have to tell our Jasmine code, we have to tell Angular that our Jasmine code is running a specific module, the module that we're interested in testing. To do that, we need to tell Angular to load that module for every single one of these tests. We can do that in a before each function, simply by calling it just like that. We're going to set the module for every single one of these functions to the myapp module. Notice there's no errors. Hooray. Okay. Now, what we want to do is we want to set up a home controller. Right now, we don't have a browser. We have a headless browser. So what we want to do is we want to set up, well, not really. We actually have Chrome running. We want to set up our browser to load the home controller, to pretend like it's loading the home controller in the view. So we have to fake what Angular gives us. We can do that simply by injecting. We're pretending that we're inside of this test. We're going to pretend that we're the injector. In order to do that, we have to inject. We have to create a local scope variable for the scope that we're interested in testing. And then we have to, the scope that we're going to be testing is the home controller itself. And so we're going to define a scope, and then we're going to pass that home controller the scope, as though we are the Angular injector. Here we go. So first, to create a new scope, we're going to use the root scope. The root scope object itself is the object that creates all other scopes. It's like the god of scopes. What's the god who creates things in Greek mythology? Zeus? Is that right? I think it's Zeus. Is that Greek? Yeah, not Roman. Doesn't matter. He's like Zeus for scopes. Okay. And the other thing that we'll want to do is we're going to we're going to use the controller service that is built in Angular that we don't have to use when we're writing our Angular apps, but we do have to use when we're testing. Okay, so first things first, let's create a scope. In order to create a scope, we have to use the root scope object like that, and then we have to call the new method on the root scope. This new method creates a child scope of the root scope. This is, right now, this is actually when Angular boots up and it says it loads our home controller. This is, thanks Siri. Oh, that's Asana telling me email is holding me back. Yeah. So, that's funny. Oh, it's under my, okay. So when our home controller actually boots up on the page, what is actually happening underneath the covers is Angular is saying, hey, root scope, give me a new scope. Or parent scope to wherever I am right now, give me a new scope. This is creating a child scope. So now we have the scope that we're going to pass into our controller. The other thing that we can do, now what we need to do is load our controller on the page. The way we can do that is simply by calling the function given to us by the $sign controllers function, and passing in a second argument everything that we want to inject, or that we're interested in testing that we want to inject into that controller. The controller itself has 3 things injected to it: scope, weather service, and Yelp service. We will get to these 2 in just a minute. For the time being, we're only interested in stubbing out that scope object. So we can simply pass in that scope object just like that. That was whirlwind. Did that make sense? What we are doing now is we are pretending we are Angular booting on the page, creating a scope, and then instantiating that home controller. Make sense? Yep. Rockin'. Okay, so now it's fairly trivial to set expectations because we have a hold of that scope to set expectations on this controller. So for one, the first thing that we'll do is we'll say it has the city of San Francisco set by default. Well, here what we're saying is after this thing is loaded, we're going to set an expectation. So we want to expect that that scope city, bless you, matches San Francisco. Just like that. So if we save this file, because we have Karma running, we should say, hey, look, we have a success. Let's reload that. We save, look, we have success, huzzah. To prove that it is actually working, let's create a broken expectation so that it should match San Francisco. It won't do this, this will fail. You can see that now we have the failure saying it doesn't match San Francisco, but it doesn't match San Francisco, so we have a failure. Hooray. All right. Does that make sense? Our first test? Everyone get that? Okay, great. Let's move on. So now that we have our first test running, what we want to test is that when we call the function getWeather4, that our weather function, our weather service, receives a call. And it receives a call with a specific city, because that's a good expectation. So if we change the city name, then we want it to be something else. We want it to get called with something else. So it calls the weather service. Okay, so in order to do this, you guys already know how to do that, how to mock the weather service. Or you guys already know how to inject the weather service into the controller. However, I will create a weather service and pass that in. Okay. So we can do a couple things. We can either inject our weather service in here, just like this, Or what I like to do instead of that is I like to inject the injector. Yeah, I know, so meta, right? I like to inject the injector so that we, rather than continuously adding things on top, we can use the injector to do that. So we can simply call it just like that, which is actually, and it's not inject, it's injector. This is actually how Angular works underneath the covers at compile time. Now, in order to tell the home controller that we want to use this weather service and not another weather service, we have to tell it to inject this weather service instead of the other one. Just like that. So if we reload if we save the page, you'll see that, oh, well, there's no, we reload the test, then you'll see that success still works. Okay. So now we want to set an expectation that that getWeather4 is called. The way we need to do that, the way we can do that using a JavaScript testing framework in Jasmine is we want to set a spy on that object. So the way that we set a spy is we use the Jasmine term spy on. We're going to spy on the weather service. And we're going to spy that it has a getWeather4 method. What this spy does is it simply replaces that function on that object with a new function that we can set expectations on. And if you don't believe me, oh yeah, this is all, by the way, in our, this is all, by the way, all these fun things will be, right. All these, all this stuff will be available on the slides, which I will make available to you when I figure out how. Okay. So now what we can do is we're going to simply call, so at the root of this getWeatherData function, we're not actually doing anything custom inside of this Angular controller. What we are doing is we are setting, we want to make sure that the weather service has the getWeather4 function called with the appropriate response. Because we would test that weather service in a different service test on its own. Does that make sense? You guys believe me? Okay. So the way that we can do that is we'll just simply, on our scope, we will just simply call getWeatherData. Does this take a? It doesn't. Okay. So we'll simply call getWeatherData, and now we can set an expectation on that spy saying, expect this to have been called. I think there's one with an if. Oh, right. So the error itself that's happening right now is what we're doing. Remember I said we are replacing this method on the weather service with something else. What we want to do is we don't want to just replace it because we're depending on that then. We're depending on something to come back from here. So we have to replace it and respond with something. The easiest way to do this is by saying and call through. This simply calls through. We're setting a spy and then we're just calling the normal object. If we wanted to, we could, rather than do that, we could return to return or something like that. I don't use that very often. I don't remember off the top of my head. Tip of my tongue? Oh, right. So if you call and call through, it's just going to actually make that call right through to the object itself. So it's not going to replace it. It's going to create a stub in front of it and then going to call right back to that method. So if we save the file, what did I mistype? What's that? Oh, thank you. Haha. Right. We actually want the getWeather4 to have been called. Thank you. We save the file, and huzzah, success. Okay. One more thing inside of controller tests, and then we'll move to end-to-end testing. Yes, sounds good to me. Hooray.
One small thing I would throw out there.
Yeah.
I like to use sign-ins, spying and stubbing instead of Jasmine personally. I don't know if anybody else is getting into this, but it's to me a little more easier to read and get better feedback.
Yeah, it's SINON is what he's talking about. It's another library that you can use instead of Jasmine.
I have no idea if I pronounce it correctly. I only know I've never met anybody else who uses this team. They call it sign-in.
I call it Sinon, but I'm the odd duck out here, I suppose. So anyway, that's another option if you want to do mocking, or if you want to do stubbing or spies. They're both. It does stubs and spies. It does it all, and it makes me coffee too. Okay. Right. So one last thing about testing with controllers is we don't actually have time. Okay, if we do have time, we'll come back. What I want to show you is the HTTP backend replace. So, nope, let's just do it really quick. Can you guys stay over for like 5 minutes at most? Yeah. Okay, cool. So, Angular works, the HTTP service works by calling something called, it's something we never have to use when we're writing an Angular application. It's called the $HTTP backend. So what actually happens is Angular, the $service says, hey, Angular backend, HTTP backend, go fetch me this thing. The reason it does that is because in testing mode, it's going to take out that $HTTP backend, so we never actually make a call to a remote service. We can set up mocks on top of it, yes. It's simply using dependency injection and replacing it with an object that doesn't actually do anything unless we set those expectations up. Make sense? Rockin'. Okay, so in order to actually set our HTTP backend, what we have to do is we have to do injector.get. We'll go get this HTTP backend. Hooray, now we have this set. 1 second. I want to go grab something from the slides. All right. So in order to actually set expectations on the HTTP backend, we have to say at the end of every single call, we want to verify that there's no hanging requests, that we have not actually made a request, or that we have made a request. If Angular is expecting there to be a call to go out, and there's still a request hanging around, we've done something wrong inside of our test. So we have to include these 4 lines, which say, we want to verify that there's no outstanding requests, and we want to verify that there's no outstanding expectations on that request. And you'll see why shortly. Okay, so if we save this file, great. So what's going on here is we're now because of that, because we're verifying that there's no outstanding requests and there's no outstanding expectations, what's happening is when the weather service is called and it's calling the getWeather4 function right here, or this getWeatherData, this is actually going out and calling to the getWeather service. So what we want to do is we want to stub that such that, our weather data is actually coming back regardless if we make that call. We're not going to set an expectation, we're going to set a stub. You'll see why I said that in just a second. The way that we set up a stub is we use the $HTTP backend. By the way, this 30 minutes that I'm throwing a bunch of information at you is a 1.5 day long class. So I'm trying to get this out for you guys. We don't have to do this if you don't want to.
Probably why I feel lost.
Yeah, are you guys finding this worth it, or should we? Yes?
It's a good preview of, we'll have to dig into it later, right?
Yes, I know a book that helps. There's 80 pages in the book on testing, if not more.
Actually do a pretty good job.
Now they do.
Like a really
Now they do.
intro.
What?
Will this be on the gist too?
No. Yeah, I'll put it on the gist. Just because I like you guys. Okay, so what we can do is now we can set up a when. When I say, excuse me, when I say when, what we're doing is we're not setting an expectation, we are setting a stub. So anytime that the specific call that we are going to be making right now gets called, nothing is going to get thrown because we won't have it outstanding. So what we basically want to do is we want to say when there's a JSON P call, when there's a JSON P call and it's called to this URL right here, and it's called to that URL, we just simply want to respond with a 200 with some data or no data. Yep. That should be fine. Cool. So the last thing that we have to do here is in our get weather is we basically want to tell our backend to just flush. So that means that if there's any outstanding requests, we just want to flush all those requests. So because we're not actually testing the backend right now, we simply want to say we don't want it to fail here. That's it. So now we can set up an expectation that weather service is actually called. The way that we can do that, it calls out to open weathermap.org. The way that we can do that is we can set up an expectation on this HTTP backend. We can say it expects a JSON P request to come in with this guy. And instead of doing San Francisco, California, we will do Phoenix, Arizona. And the reason why we'll do that is so I can prove to you guys that we're doing stuff. Makes sense. We simply want to just respond with a 200 and some data. Excuse me. Now what we can do is we can call get weather data. And then we want to flush this to backend, flush. I think that will work. Responds. I think it's responds. And responds. Oh, wait. I think it should just be responds. Or it might be just respond. OK, cool. It's respond. Sweet. So now we have a failure. The reason why we have a failure, can anyone tell me why we have a failure? It's pretty easy. Yeah, we're making a different call. We have this call. Oops, we have a call coming in with San Francisco. We don't have a call with Phoenix. The reason why we don't have a call with Phoenix is because it's calling with the city that's on the scope. We can change that city simply by saying, oh, just like that. Now that call should be coming through. Hooray. OK. Unit testing, one of the reasons you do unit testing is because unit testing is super fast. You can see, as soon as I'm saving the file, all the tests are done. I can't actually catch them running. They're super fast, and they're fast for a reason, because we actually have access to the code. On the other hand, end-to-end testing is not super fast. It's actually very slow. However, I'll show you how to do it. OK. So in order to do end-to-end testing, we're going to use something called Protractor. Protractor is the new hotness in Angular testing, in the Angular testing world. Protractor is a library that sits on top of the WebDriver. What that means is we have access to a whole bunch of different browsers that we can run our tests against. It's also very well battle tested and in production, and it's a lot of fun to use. You'll see why shortly. OK. So now that we have Protractor installed, we want to do two things. We want to install the WebDriver. The way we do that is by using the Protractor tool called WebDriver Manager, and we call update. This might take a little while. Oh, that's so unfortunate. All right, one sec. Let's go grab this from my other. Okay, so because we're testing with WebDriver, we're testing with Selenium, what we need to do is we need to launch a Selenium server. There are a lot of, what?
You guys know what Selenium is?
Yeah, do you guys know what Selenium is? Yeah. Do you not know? Does anyone not know what Selenium is? Okay, cool. Good question, though. We need to start a Selenium server. If you don't want to run one, you can run one. There are services that will do this for you. You have to pay for them, obviously. Or you can run your own if you want to launch your own on EC2, or your company has one. Company likely has one. Selenium is very well distributed out in the production world. Okay, anyway, so now in order to actually launch this thing, we need to run it. And the way that we'll run it is by using Selenium, by using the standalone Selenium, at least locally, to launch our Selenium server. Protractor makes this really easy. Okay, so the next thing that we'll want to do is we'll want to copy a reference implementation or a reference configuration into our local directory. And this comes directly inside of when we install Protractor. You can simply just grab this from your Node modules Protractor directory. We're going to change a couple things inside of here. First, we're going to change the Selenium address. And then we are going to, oh, nope, that's all we have to change. Okay, awesome. Okay. So now we're going to create our first end-to-end test. And we'll call this the home spec test. Selenium uses Jasmine, the Jasmine API by default. You can change it if you like other APIs, if you like other testing frameworks. I happen to like this, so I happen to like Jasmine. Okay, so unlike Karma or Testacular, unlike Karma, when you save the file, it doesn't run automatically, and it does this for good reason because end-to-end tests are really slow, and it can, when you're constantly saving your files on your system, you don't want those end-to-end tests consistently running. You just want to run them when you're ready to actually look at the output. So we will have to launch those manually. Okay, so one thing I'd like to do first, before I do anything else, is inside of our, oh, good, it's already running. Never mind. Cool, so what we want to do in each of our tests is we want to load the home route, because we're testing right now the home page. So what we can do is we can call browser.get. Browser, by the way, is a global object exposed by Protractor. So you can just call browser and browser things on top of that. For every single test, we would just want to load the home page. OK, so let's set an expectation saying that the home page itself has a search box when we first load up. We can do that simply by saying it has a search box. This is on the home page, of course. So the way that we'll set expectations inside of our end-to-end tests is we will search for elements inside of our page, and we will take those elements and we'll say, hey, we want to make sure that this element is actually on the page. We want to click on this button when that button is there. We want to see what happens when we actually make actual real-life calls. Okay, so the way that we do that with Protractor is we're going to search for an element, and one of the nice things about Protractor is built to be compatible with Angular, which means Protractor will wait for our Angular app to load. Protractor will wait for our HTTP calls to come back. Protractor will resolve promises when we have a promise that it's expecting. Protractor is awesome when you're writing Angular apps. Protractor is less awesome when you're not writing Angular apps or you're interacting with non-Angular Angular APIs. The short of it is Protractor is awesome. I think I sold that pretty well. Okay. So we can do, there's a bunch of different ways that we can search for elements. simply because we're only looking for a single element, and that single element here is the form element input box. What we can do, let's just add an ID here, search input. We can search based on CSS. So we can use a selector called CSS, and we can say, hey, grab this element on our page, and we just want to expect, we want to set an expectation that that element is to be defined. So now we can go run our protractor tests. Node modules, protractor, bin, protractor. The way that we run our protractor is we simply use the protractor binary and we pass it the configuration file. Object is not a function. Yeah. Yeah, it's to be defined. By model elements by. Oh. Yeah, that's right. Does not compute. Okay, I did something wrong. Right. 1 second. Do you guys see what I did wrong here? I think it's pretty much the same. Okay, I don't see it. No, that's expectation. It's right there. Okay, so pretend that works.
Pass if you don't have any assertions inside of your test.
What's that?
I said, are we green if you
Yes.
comment out your assertion?
Yes. Before each. Oh, maybe not.
Seems like a potential configuration problem. Or is it running
Once.
test inside of there?
Oh, it might be. Home spec. No. Oh, our root element is our body. 1 sec. Nope, that's right. I only have one. Oh, okay. Interesting. I was trying to run that smoke test. That explains it. Okay, cool. Hooray, it worked. It was a configuration problem. Okay, cool. The last thing that I want to show you is one of the really awesome things about Protractor is the fact that it can pretend that it's a human being typing things, and it can pretend that it's actually interacting with the page. So let's just real quick. It searches. It gets the weather. So what we can do is we can actually inside of our test we can say by city that we want to actually type in a city here. And then we want to set an expectation. Oh, whoops. And then we also want to click element.by CSS. Yeah, okay, we'll just do that. button type equals submit dot click. Then we want to set an expectation that the element that is populated by weather. We'll set an ID here for ease, weather. Okay. Oh, this is one of my favorite parts about this. Oh. Oh, wait. Did I not add a function? Nope, I didn't. Okay, well, I think you guys get it. Oh, wait, I totally forgot. Element.getText. Okay, cool. So the browser loads, it starts typing things, and you can see it loads, and it waits for that HTTP request to come back. It's waiting for both of them, if you'll notice. In this case, it failed because we're actually typing in a new city, and we're expecting it to have the old city information in there. So you can see if we change this to Phoenix, the weather in Phoenix is, and we can see that when we reload the test, we'll see it's typing things in. It's loading the weather. Wow, it's hot in Phoenix. It's waiting for those requests to come back, and then, hooray, our test pass. That's a lot faster than clicking through the application and typing things in and pressing enter and hoping things work. This is a verifiable way of doing it. Whew. Are there any questions? Okay, I'll make sure that all the tests are available on the gist as well. So if you reload later today, it'll be available.
So you're actually going out to the actual website?
Yeah.
Yeah, because some people say it's not good practice.
So when you're doing black box testing, you have to go to the web. You have to. Like, basically, there's no way to possibly set up a black box test the way that your user will experience it without actually going to the website. This is why this is why A, end-to-end tests are slow, and B, why unit tests are fast, super fast.